Welcome to Daily Papers.
Imagine that famous scene from The Matrix, the one where Neo dodges bullets, the action freezes, and the camera swings around him in a perfect circle. That effect is called bullet time, and it took a room full of cameras all firing at once to create it.
It's an iconic moment in cinema. But what if you could create that same effect, or any other camera move, with any video you have on your phone? What if you could not only move the camera around after the fact, but also rewind, fast forward, or slow down the action, all at the same time?
That's the incredible promise of a new AI model from researchers at the University of Cambridge and Adobe Research. The paper is called SpaceTimePilot, Generative Rendering of Dynamic Scenes Across Space and Time.
And it's a fantastic name because this AI is literally a pilot that can navigate through both the space and the time of a video, completely independently.
So let's break down the problem they're trying to solve. For a while now, AI has been getting pretty good at what's called novel view synthesis. That's a fancy way of saying you give it a video and it can generate what that scene would look like from a different camera angle.
Right, you could take a video of someone dancing, filmed from the front, and ask the AI to show you what it looks like from the side. But there's a catch. If you also asked that AI to show the dance in slow motion, it would get very, very confused.
Exactly. The AI models would tend to think that the camera's movement and the action in the scene are tied together. They're entangled. So if you tell it to slow down the dancer, it might also slow down the camera movement you asked for. You can control the space or you can control the time, but trying to do both creates a mess.
The core breakthrough of SpaceTimePilot is that it learns to disentangle those two things. It understands that the camera's position in space is one variable, and the action's progression in time is a completely separate variable. It's like having two different dials you can turn.
So how on earth do you teach an AI to think like that? The first challenge is data. Ideally, you need a massive data set of videos showing the exact same scene filmed simultaneously from hundreds of different angles. And for each of those angles, you'd also need versions in slow motion, reverse, and fast forward.
A dataset like that just doesn't exist. It would be practically impossible to create in the real world. So the researchers came up with a brilliantly clever training trick they call temporal warping augmentation.
It sounds complex, but the idea is simple. They took existing video datasets that already had scenes shot from multiple viewpoints. Then they digitally created the time-manipulated versions themselves.
So they'd take a video of a person walking, and they'd programmatically create a new version where the person walks backwards. Then they'd show both to the AI and essentially say, see, this is what forward looks like, and this is what reverse looks like. Learn the difference.
They did this for all sorts of time effects, slow motion, pausing the video at a specific frame, even a zigzag motion that goes forward, then backward, then forward again. By creating these artificial training pairs, they gave the AI thousands of examples of how to manipulate time separate from any camera changes.
That trick alone got them great results. But to really perfect the model and give it the finest level of control, they went one step further. They built their own virtual world.
They created a brand new synthetic dataset called Cam Cross Time, or CamX Time. Using 3D animation software, they rendered dynamic scenes like a person dancing or performing an action. But they didn't just render one video, they rendered it from every conceivable camera angle and at every single moment of the animation.
It's like they created a massive grid. One axis of the grid is the camera's position, and the other axis is the timestamp of the action. Then they generated a frame for every single coordinate on that grid. This gives the AI the perfect, unambiguous cheat sheet for learning how to separate space and time.
And the results are just stunning. The paper shows several examples. In one, they take a video of two ballet dancers. The original video is just a standard shot. They then use SpaceTimePilot to generate a new video where the action is in slow motion, but the camera is smoothly panning across the stage.
There's another one with a couple doing a retro swing dance on a bridge in Paris. They can freeze the dancers mid-twirl and have the camera swoop around them, just like in The Matrix. The model understands that the dancers should be frozen in time, but the camera should be moving through space.
It can even do reverse motion. It takes a video of a couple in Baroque costumes dancing forwards and generates a new clip where they perform the dance perfectly backwards, all while the camera follows a completely new path.
This really feels like a leap forward for video editing and content creation. A filmmaker could fix a shot in post-production, maybe shifting the camera angle slightly. A YouTuber could add a dramatic slow-motion zoom effect to a clip without needing special equipment.
It fundamentally changes what a video is. Instead of a flat, fixed recording, a video becomes a 4D block of data, 3 dimensions of space and 1 of time that you can explore freely.
This SpaceTimePilot gives creators the controls to navigate that 4D world however they want, generating entirely new shots from a single piece of source footage.
It's a powerful idea, turning every video into its own virtual movie set. By cleverly solving the data problem with temporal warping and their new synthetic dataset, the researchers have successfully disentangled space and time, giving us a glimpse into a much more dynamic and controllable future for video.